Black holes have been predicted by Einstein in his theory of general relativity. They are objects so massive and compact that not even light can escape them. This makes them fascinating objects both for astronomers and for the public. But there's a horrendous amount of misinformation about them that can be found on the internet. Let's correct the most common 10 misconceptions about black holes. Misconception 1. Black holes are actually holes. The name of black holes is misleading. They are not actual holes, but spherical objects, just like the Sun or our Earth. There is no other side. Misconception 2. There is only one black hole in each galaxy. The most famous black holes are the supermassive ones, which lurk in the centers of most galaxies. We will talk about them later on. But they are far from the only ones. There are millions of black holes in every galaxy. They are the remnants of massive stars after they ended their life in a supernova explosion. The closest such black hole is only 3,000 light years away from Earth. Misconception 3. Every star ends its life as a black hole. Only the most massive stars, after exploding as a supernova, collapse into a black hole. Most stars, including our Sun, don't end their lives in such a spectacular way. In the best case, they create beautiful planetary nebulae, but most just fade away into darkness. Misconception 4. Supermassive black holes can be seen in the bright centers of spiral galaxies. One of the most common questions I receive when I present images of spiral galaxies is, why are their cores so bright if there is a supermassive black hole? Or, is the bright center caused by a black hole? The answer is that the bright center of spiral galaxies has nothing to do with the black hole after all. These centers are the galactic bulge, a region of space containing billions of older redder stars. The supermassive black hole, if there is one at all, cannot be seen in any of the beautiful images of distant spirals. Misconception 5. Black holes are cosmic vacuum cleaners. Perhaps the most prevalent myth about black holes is that they suck matter towards them, like really powerful vacuum cleaners. But that's far from true. They don't roam space and eat planets for breakfast and stars for lunch. They will not consume everything in the universe, and you don't have to be afraid of them. Why? Well, even though black holes are extreme in many ways, they don't have infinite mass, and it's mass that determines the force of their gravity. This will be important later on again. Most black holes, known as stellar black holes, have about the amount of mass that a normal massive star has. So just as objects can orbit a massive star without falling in, the same is true for black holes. You could happily orbit a black hole forever. Once you get close enough, the story is different and gravity will guide you in. But it's the same as any massive object, like a planet or star. Misconception 6. We do spiral into the supermassive black hole in the galactic center. A common misconception is that spiral arms of galaxies are interpreted as a stream of matter slowly falling into the supermassive black hole at the center. However, as we just learned, black holes are not cosmic vacuum cleaners. And spiral arms don't move inwards. They're a static phenomenon, and the stars within them stay in their orbit around the galactic center without getting closer to it. Misconception 7. Black holes hold galaxies together. Many people think that the supermassive black holes, which can be found in the centers of most galaxies, hold a galaxy together. However, this is far from true. We can easily calculate the sphere of influence for supermassive black holes, in which the gravitational potential of the black hole dominates over that of the host galaxy. When we plug in the numbers for Sagittarius A star, the supermassive black hole in the center of our Milky Way galaxy, we find that its sphere of influence has a radius of about 10 light years. This is a tiny radius compared to the galactic scale. Keep in mind that our Milky Way has a radius of more than 50,000 light years. Misconception 8. Supermassive black holes are the dominant mass in a galaxy. Supermassive black holes are the most massive individual objects in each galaxy. However, they are outnumbered by billions of stars and huge amount of dark matter. You can get a feel of how insignificant Sagittarius A star is by just comparing its estimated total mass to that of the Milky Way. Sagittarius A star is about 4 million times the mass of the Sun, while the total mass of the Milky Way, stars, gas and dark matter, is in the order of 1 trillion times the mass of the Sun. That's a factor of almost 1 million times more massive. Misconception 9. The density of a black hole is infinite. This one is a tricky point and half true. It is correct that theoretically a singularity at the center of a black hole has all its mass compressed into an infinite small point, creating an object with infinite density. However, the only way we can realistically determine its density is by measuring the size of the Schwarzschild radius and divide the volume created by this sphere by its mass. This gives us the density of the Schwarzschild radius, and the result is impressive. The more massive a black hole is, the lower is its density, down to only 1 kilogram per cubic meter. That's 1,000 times less than the density of water. Misconception 10. The stars of the Milky Way rotate around the supermassive black hole. We've already learned that the supermassive black hole's gravitational influence reaches out to about 10 light years. This area of influence is actually so tiny that only about 100 stars or so live there, compared to the estimated 200 billion stars in the Milky Way. Only those 100 stars can be said to orbit the black hole. And we do actually have observed these stars and their orbits with ground-based telescopes. Our solar system, however, is located more than 30,000 light years from the center. Our solar system hence couldn't care less about the presence of a supermassive black hole in the galactic center. Our Sun and the billions of other stars in the galaxy do orbit the barycenter of the Milky Way, the common center of mass created by the total mass of the galaxy. As even the mass of a supermassive black hole is tiny compared to the total mass of the whole galaxy, it doesn't really add that much to the position of the barycenter. Again, removing it wouldn't have an effect on the galaxy overall, just on the 100 stars in its direct neighborhood. These were the 10 most common misconceptions about black holes. Keep them in mind the next time you're part of a discussion about these fascinating objects. And stay tuned for the next episode of Star Stuff.